So hi everyone. My name is Raz. I'm from Nekuda. Nekuda is an innovation, design, and development company in Israel. I'll tell more about this later. So first of all, I want to thank you for having me here, and I want to thank all the participants for being here. So I'm here to talk to you about an AR project that we did for Flex last year in the context of design as a leader. So I'm a designer and a project manager, and I'm already apologizing ahead of time because I manage this project end to end, and it is full of details. So I will try to talk less about the details and more about the big picture in this message of design as a leader. So with your permission, let's start with like 10 seconds of Hollywood.
At your service, sir.
Gauge heads-up display.
Check.
Four-door preferences from home interface.
Will do, sir.
All right, what do you say?
I have indeed been uploaded, sir. We're online and ready.
We start the virtual walk-around.
Importing preferences and calibrating virtual environment.
Do a check on control surfaces.
As you wish.
Yeah, tell you what, do a weather and ATC check, start listening in on ground control.
Sir, there are still terabytes.
So that's enough. We can go back to the presentation. Basically, talking about design as a leader, it's enough to see a Hollywoodic film to understand how design can be a leader. Let me continue. So in recent years, the vision of AR, VR is this: designing a cool headset for the home consumer, using AR for entertainment, but in reality, this is not happening yet. And this is not where the AR technology is heading at the moment. Actually, as you can see here, this is the environment. These are the users doing this scenario. So the AR world is developing to support enterprises and less the home consumer. Here are two examples, relates also to the presentation that Sefi showed. So we've got here some examples are of products of AR devices. Yes, okay. How they designed more and more to be B2B oriented and less B2C oriented. And so our brief, going back to this slide, was to design a real industrial grade AR device, and I say real for a reason. I will explain about this later. I just want to, before we dive into the project, just to quickly introduce ourselves for you all. So we are an innovation design development firm, as I said, from Israel, designing for the last 22 years. We work in a whole range of fields, end-to-end and multidisciplinary with design and engineering. We do innovation, design, mechanical engineering, and of course, we manage everything together. We work very organized and believe this is also critical for the design. This slide of our methodology, thank you. This slide of our methodology, it's a slide I'm going to come back to several times as I will explain about the process that we did and the steps that we took in the project. Our design philosophy is user-centered, so in the beginning of every project, we take the time to understand the user, understand the environment, and understand the scenario. In the world of HMDs, we've been designing for the last 22 years. We understand the challenges, we know the systems and the subsystems within. We build use scenario, we provide ergonomic solutions, mechanical details, and of course, we design them. So going back into the project, we were the design team. We were one team out of several. You can see here a picture from one of the workshops. And actually, you see here 20 people, but we were around 70 people working on this project. We were the design team, but what you see here in this picture are several disciplines. You've got the electronic engineers, and you've got the optic people, and you've got all the different technologies. And this is why I want to say that inside an AR device, you've got a lot of technologies. You've got the sensors, processors, lenses, wireless communication, thermal solution, and etc., all being developed by different disciplines. And in the center, you've got the user. And the user doesn't really appreciate the technologies. The user appreciates the experience that he gets from those technologies. So here is where we see the role of the designer, to mediate between the technologies and the user by the design. We believe that designers have the responsibility to provide a wider look at the product, to understand the context of the product, and to make sure the product becomes a one-piece holistic unit, although several disciplines were working in the development. So in this case, what I'm going to discuss are 4 key areas of knowledge that we think and believe are important in order for design to lead technology. The first one is to define what we need. The second one is to set a vision of what this product should be. The third one is to ensure best usability. And the fourth one is to help engineering be as close to the design concept as possible. So going to the first topic, the framing, as I said in the beginning of our methodology, the main purpose is to align everyone and to define what we need. A good, tight framing will save time and effort as the project continues and will allow easy trade-off decisions between the different teams. So over here, framing an industrial-grade AR device. So we started asking ourselves, what is an industrial-grade AR device? So we looked at the environment, and we looked at the users, and then we mapped and detailed the scenario deeply to understand exactly how this product acts. We researched the benchmarks using in those environments, and this is what I was saying about real industrial grade, because there are products being used in the industrial area, but they are compromises. They are good AR devices, but they don't fit the environment. Mean they are not waterproof, they are not dust ready, they are not eye safety compliant, and etc. So we collected all the requirements and certifications needed, and with the client, we sketched the system we need to design. So going quickly to the second area, so every HMD needs to fit a range of people. And now in this project, Flex defined fitting 100% of the adult population, which means from the 1st percentile to the 99th percentile of head sizes. And same for head forms, because as you can see, different races have different head forms. And when you're dealing with optics, those differences are noticeable and quite challenging. Another important issue is the weight issue. You can see here mock-ups and models along the way just to optimize the distribution of the weight. And we started to develop the ergonomic system. Here is the front pad, for example. A combination of different materials and different geometrics. Of course, prototyping everything along the way just to make sure that we've got the best solution. And by the end, we actually patented the ergonomic system with Flex, creating a new way of donning and doffing an HMD. Going to the design engineering, here are just some slides I will show quickly just to understand how tightly packed and integrated this product is. You've got all of the optics, and you got the chassis, and you got the heat sinks, so you've got all the electronics and the mechanical details inside, all being codependent on one another. So we needed every time to zoom in to see how we can optimize a specific system or a part, and then to zoom out again just to make sure that we still have an holistic look for the whole product. And this will give, I will go to the industrial design itself. So this is the second phase in our methodology. So actually, we do touch the design already in the framing when we collect attributes, and then in order to communicate the design for the client and the rest of the team, we build theme boards, and then very early on, we create a teaser. The teaser is based on the knowledge that we got until that point with all the components and the constraints. And in the design phase, we take the teaser, and we actually making a lot of other variations of it. So the client can have several variations. It can choose the things that he likes. And you can see here the choice that the client made. And at this point, we set the vision of what the product should be. Then we move to implementation. The implementation is, again, the next phase where we build everything in 3D, taking into account the smallest details, taking into account how parts are going to be connected, and how the assembly process is, and playing even with more colors and finishes just to accurate the CMF. So here is the final product. You can see some renders of it. כל מה שאני צריך. So here's the final product, as you can see, and it's basically a true AR, a true industrial tool to use in rough environments. And I just want to finish this presentation by sharing some of the learning that we had from this experience, so in 3 levels. On the individual level, the first level, you want to build an individual that can be an expert in his field, that will know to ask the right questions, because asking the right questions is the key for developing a good product. And as an expert in his field, you want him also to overlap just a little with surrounding fields, neighboring fields, just enough so he can debate and even challenge other experts. On the team level, second level, you want each team to own responsibilities, to rise up to challenges, and to deliver. You want all teams aboard sharing the same vision. That means including you and the client. And we can enable that by adopting a culture of equality, critique, and action, directness and openness of all, for getting criticism and for improving, and to make sure that although there are several teams inside the product, inside this project, we are all a part of the same team with the same goal. And finally, the methodology, which is very important to control the whole process. This to make sure the project moves forward and not backwards. You want it to cover all disciplines, and within it to generate clarity and sharing. So thank you.